If you got the Tasco 302012 telescope with the charts, as I did second-hand, they sent the charts and the paperwork with me when I got this second-hand. You'll have a moon map there, and then you can use this moon map here from pictures you've taken or videos you've taken here. As you're looking at your video, you can start to identify some of the craters. This is a very large map here. It's called a Rand McNally official map of the moon. So basically that's what you can do, or find a book that's got a decent moon map, and I showed you one before. The moon is a fantastic target for astronomy, and no matter how long you've been doing astronomy, even if it's cloudy, there is a chance it might reappear for, just for a few minutes, and that's worth getting the telescope. This telescope was made around 1990, and that it's now nearly 2018, so it's 28 years old, but it's been kept in an attic somewhere. I bought it second hand, had to fix it because it had been set up wrong. It also came with a basic map of the solar system and human endeavour in the solar system, what we knew by around 1990. So there you go, there's a solar system there mapped out with some basic data on a map. You've also got a booklet called Reach to the Worlds Beyond, and that's where I got hold of my sidereal chart of how to find out how to set up my telescope, and that showed you various different telescopes, how to focus, balancing in telescope, finder scopes, and equatorial mounts. Okay, and also gives you some observing guides. These are the right ascension and declination positions of some common objects you want to look at. Obviously the sun varies. Distant objects, stars. This is what you dial up when you look at them on your telescope. Right, how could I dial up finding a star now that the sun has set? And it's on my computer. The time's coming up as being 3 minutes past 5. Okay, so at sidereal time, if it was 8 PM, is 2:33, and basically I am only just after 5 o'clock, so I'm 3 hours short, just under 3 hours short. So if I knock off 3 hours off that and put that on my clock, I should be correct. So in other words, 3 hours off that will make it 11:30 or 23:30 on a 24-hour clock. So basically I go over to this dial here, which is my right ascension dial here, and I need to, where between those two marks is there, okay, on that dial there, I'll need to dial up 23, okay, so 23:30, so that's 23 there, and each one's 10 minutes, so that's 1, 2, 3, okay, and I've gone slightly past that, so give a tiny little tweak there, and I should have correct sidereal time. That means now, as long as that lines up there and stays there, I can dial up using this pointer. This is the pointer on the telescope, whatever coordinates I want to dial up with this and that, which is my declination of a star or an object in the sky, and it should, if I've got it correctly, appear very close to being in my eyepiece when I look. It won't be exact. This mount is not totally stable. It's not the best mount in the world, but that's why you've got these adjustments here. For instance, there you go, and that's what you're looking at through your eyepiece of your Tasco telescope. And there's trying to get the whole eyepiece in if I can. There you go, it's a bit better. And you can see it moves quite quickly across the sky, and that's why you need your tracking on your telescope. Difficult to get the whole of the limb in on it, but I've got I changed the eyepieces on the Tasco, and I'm using a zoom that I got off a Bresser. There you go. So the moon is obviously many people's favourite object for observing, and certainly will give you many hours of enjoyment. There's the craters there, a load of craters. Don't forget your image is upside down. Perfect beginner's telescopes. The tripods are quite heavy on the Tasco, but on the other hand makes it a little bit more sturdy because they're wooden. That's a bit better. There on the videos you can see more detail there, but the clouds are going to eventually get it. Here where I live in the UK, that's always what's going to happen, but there you go, and it's gone. Try filming through a sunglasses shade. If the moon is overexposed on your video camera, you should get better results. At 640 by 480 it's much better on video looking at the moon. I put sunglasses in front of the lens of my ordinary camera, and this moon, which would be far too bright, as you can see, you might need to use 2 layers of sunglasses on it, but it just takes off the edge. There you go, you see the difference? Moon in one go. It's not full phase at the moment. There you go. So it's one way around it of eyepiece projection. If you just adjust the focus using your own telescope focus, I'm using the focusing knob for this, and then move around the moon gently using the telescope's slow motion controls. Here you go. As you can see, that's the eyepiece view. You've got some craters there. Hold it steady and zoom it up a bit. And this is what you can see through a telescope eyepiece, basically. Looking at the moon. I'm tracking across it if I can. Show you some of the Terminator, there you go. A bit better. There you go, you can focus on one region. Hold your camera a bit steady. And you can see around a bit just on one part of the moon in your camera. If it gets a bit blurred, then just go to your focus knob of your telescope and give it a slight tweak, and you should get better views on your camera. There you go, it's moving around. There you go. And if you reach the limb of the moon, I'm holding the eyepiece gently because I've got the telescope balanced, so it's easy to move around. There you go. There's the limb of the moon there. Just there. Obviously, if you've got things clamped, you can see better, but just for a rough quality check of a Tasco scope, gives you an idea, doesn't it, of what you can see on the moon.
There you go. So I'm basically a fair old distance from the moon. Eyepiece here. Just giving you a rough idea of what the Tasco view looks like of the moon. It does look better than this through your own eyes. This gives you a rough idea of what you're going to see through an eyepiece. And there's some crater rays there you can probably see. And Maria, which are the so-called seas on the moon. Not really seas, but you know, the lava that's flown. Again, use the telescope focus to try and get it to focus better on your video camera. I've zoomed in, zooming back is better actually. There you go, and it should snap into focus. There's some craters there. So this should be your first sort of object. There you go, you see there's a nice crater there. And you can try and focus on it a bit better. And the moon moves quite quickly across the sky. Like any celestial object, you've got to keep moving your telescope gently. You can use the slow motion controls. There you go, there's a crater there. And you can use your moon map to identify your crater. So for a beginner, this is your first object. There you go. And I'm videoing this through my ordinary video camera at quite a distance from the eyepiece. But the idea is using eyepiece projection by actually changing the focal length using the telescope. And I don't know that anyone's ever mentioned this before, but that's what I'm doing. I'm actually just focusing. You can probably zoom in a bit more. That's it. And I'm just projecting. I'm not even using a tube to project. I'm just moving around. If I zoom out, you can see that I'm just looking down the eyepiece there. The moon and the sky. It's quite spectacular actually. There you go. Try and get. There you go. And it's eyepiece projection. So you need to focus. There you go. That's better. And then you can just, if you hold it steady, the moon itself will be moving. And you can move around a little bit if you move slowly. There's a limb there. That's the boundary to where the sun's rays hit the moon. It's thrown into shadow. That's where we get the fantastic contrast. It's the way that Galileo measured the height of mountains on the moon. When the moon was at first quarter, he realised there was a right angle formed, right angled triangle, and he was able to calculate the heights using shadow triangulation. And of course you can get moon maps so you can actually identify these basic crater and the Maria. I'm just doing a little tour around the gibbous moon here on my little handheld camera eyepiece projection. There you go, there's a limb there. It's shaky of course, so I haven't got it held on a tripod. I'm just giving you an idea of what you can get with a very basic 114mm camera telescope with a video camera just held up. So it is quite fun really. You know, that's zoomed in. I mean, it's moving of course. You are able to see quite a bit of detail. There you go. Again, if you worry about your focus, use your focuser on your camera, on your telescope, just to sharpen up the eyepiece projection a bit. And you've got various crater rays and bright spots where bombardment within the solar system over billions of years has created these. Of course, on the Earth, the same bombardment sort of happened, but we have much more volcanic activity and it covers a lot of it up. On the moon, it's thought to be quite a barren world, so there you go. There you go, you can see the moon's moving itself in the sky. I've kept the telescope still, and there's a limb there of the moon there. So eyepiece projection does work handheld, as long as you are calm and wait for the moon itself to move along and just mess around with the focus on the telescope. And this is only 640 by 480 video I'm doing here. But you can get a picture, you can actually see, you know, basic bit of detail here. This image is upside down, of course, because it's a Newtonian telescope. These craters here are on the south of the moon as viewed in a map. It's a very crowded area where you can see this massive impact there, here moving towards the south pole of the moon. But if you look at these video images on your computer, you can use a moon map to identify the craters and also identify which ones are actually on the terminator of the moon. Here you go, and even though it's quite misty, you can see that through the eyepiece there I can see, if I zoom it up a bit, here you go. There's some detail around the south pole of the moon. Just holding it steady. Zoom out a bit. Going a bit closer. And I'm using eyepiece projection, so it's basically making the image larger. If I move around the moon a bit, there you go, there's a limb going down. And zoom out. It's quite misty up there now. Best